Welcome to Your Space Journey, where we venture into the future of space exploration and the incredible leaders who are taking us there. Here's your host, Chuck Fields.
Hello, thanks so much for joining me today for our Around the World series in space. We're going to continue this week with the Canadian Space Agency. But before we go there, I'd like to share a space story from someone you may know. Her name is Kate Pearson. She's with the B-52s.
Space sounds have always influenced the B-52 because we have so many songs about outer space. We have There's a Moon in the Sky for the Moon, and it's that New Modine about an abduction, and we have Taxi has references of space junk and laser bombs, and we have Moon 83 and just a lot of space songs. But they're all like this forward-thinking. Like, I do love Elon Musk. He's a genius, and he's funny, and he's also so optimistically and way grandiose forward-thinking about outer space. But yet he has the goods. I mean, he's really launched rockets into outer space. Teslas are awesome cars. And he's really a forward-thinking genius. And this whole thought of building underground tunnels to alleviate traffic. I mean, he's got way too many ideas to probably accomplish, but I love that he's a positive thinker and he has humor and he loves music.
Your Space Journey.
Now on to our interview with the Canadian Space Agency. I'm so pleased to introduce my guest for today, Ken Podowski. Ken works as program manager for the Lunar Gateway at the Canadian Space Agency. The Canadian Space Agency was established in 1990, but Canada has long been involved with space for decades. In fact, Canada was the third country to develop and build its own satellite, Alouette, that launched in 1962. CSA is well known for its development of Canadarm, the robotic arm used on the space shuttle, as well as the International Space Station, and soon the Lunar Gateway.
Your Space Journey.
Now, Ken, one of the things that we love to ask our interviewees is, how did your space journey begin? Was there a memory in childhood or something you're willing to share that sort of sparked your interest in space?
Oh, wow. I think it's kind of the same story for a lot of us, right? I think this is sort of, I've always been kind of plugged into the Star Wars and Star Trek stuff and kind of followed all that kind of stuff. Career-wise, I was kind of going down a path. I was all set to be a machinist, and that was something I really liked. I liked building stuff and everything, and that's still true today. I got all these home projects outside with building gazebos and trellises and patios and pool decks and cottages and stuff. And so I'm right up my alley. But the machining thing, I went in. I was heading towards. I did my college degree. I was thinking about taking like a professional program, and then I got in. I was working as a machinist, and I actually had a couple pretty good little accidents where I didn't do a lot of damage, but I really scared myself in terms of losing a couple fingers.
Okay. And
I really kind of reevaluated, and I thought about it, and I said, Ken, maybe this is just not quite the right angle. So how did it go from there? I looked at prolonging my education. I went into university. I did the mechanical engineering thing. I found my way into aerospace. Then I did a master's program in aerospace engineering. I got a job in engineering, and I had to do we call it a stage, so it's a work opportunity. Mm-hmm. And while I was doing that in school, I was doing, my career was kind of going one way, and I was actually in the pharmaceutical R&D device industry.
Really?
And then I was kind of doing the aerospace engineering at night. And it just, I just got to that point where the elastic band was just stretched way too tight. And I said, I got to make a sort of decision here. And I told my boss at the time, and actually he was just fantastic. He told me, he goes, Ken, you got to do the things you dream about. He goes, it's the only way you're ever going to be happy. And honestly, that's exactly what happened. I got in, I started off at the Canadian Space Agency. I got in there as a contractor, and that was back in 1995. So that means, actually, it's next month. That comes up on 25 years I've been at the Canadian Space Agency.
I'd love to talk to you about that. I'm sorry for interrupting, but that was one of the things that intrigued me, is that Canada itself has been involved in space for decades. I mean, it was the third country to build and its own satellite in 1962, but the Canadian Space Agency didn't form until 1990. So I was going to ask you, how did your career begin at the Canadian Space Agency?
Yeah, well, I mean, exactly that. They were at the time, so like in 1995, they were getting ready to go hardcore on ISS, right? So International Space Station, Canada had a really big commitment in terms of putting together the mobile servicing system with Canadarm3 and everything.
Mm-hmm.
And I kind of came in right exactly at the right time. I came in when all the operation stuff was sort of taking shape. So like coming in 95, and then we can talk about all the launch dates that were supposed to happen for ISS.
Sure.
But at the end of the day, we launched in 2001, and I kind of got right on that curve, and it just fit so great with what I like doing. I mean, it was the whole space thing and everything, but then it just sort of fit into that, and I mentioned before, I like building stuff, right?
Right.
And I mean, I started off as an analyst doing dynamic analysis for robotic operations and planning those operations.
Nice.
And I basically got to step through the whole system, and I wound up being program manager for Space Station program. And I mean, I'm so unbelievably proud to say that I was involved in building the International Space Station. Like that's a story I'll get to tell my grandkids, and like you do that, you get involved in that kind of a program, and it's just fantastic. And I'm so happy that Canada has that opportunity, like that we're a player in that game, right? I mean, it's great to have, a neighbor like you guys, and you guys really take that leadership role in sort of laying out these programs and creating these fantastic endeavors. And then it's just a great thing to have these partnership opportunities where we get to do it together. And it really, I mean, I'm very proud of like my career and what I've been able to do as an employee and as an engineer. I'm so much happier than that Canada has a space agency, that we got to get involved in this partnership. And that, like on Space Station, for example, like I mean, this is where I'm gonna sound like we're tooting our own horn here a little bit, okay. But I mean, we really stepped up in terms of being able to do all the things that we were able to do on Space Station. And it was a precarious relationship, right? I mean, NASA kind of brought us on board, and they were really ready to kind of step in there and put their arm around things and have to take over if they had to or whatever. But I mean, we kind of stepped up and got in there and really pulled it off. And today the stuff we do with robotics now on Space Station is it's phenomenal. Like I never thought we were going to be able to do all the things we said we were going to do. So it's just fantastic to have pulled it off. And now, like the Gateway thing, people ask me, how can you leave a program like Space Station and step into like the unknown and do Gateway? And I got no other answer to say, like, I'm just addicted to it. I can't say no. I can't
I love that.
Go, like I had this conversation with my wife. I mean, this was, a couple of years ago now. And I just, how do you say no to the moon? How do you say, like, they're going back and I got a chance to go and get in on this? And it's, and Canada's doing it, and I've got a role to do in it. And I just like, I get goosebumps just going over that. And I think that's
we need people like that. I think that is so neat, because again, it's your enthusiasm and your passion. I mean, your passion's coming through on that. And I think a lot of our audience might not know just how, like you said, Canada stepped up to the plate for the Canadarm. I mean, we had the Canadarm version 1, I guess, in the space shuttle launched, second mission of the space shuttle in 1982. And then you came on board with Canadarm2, which is on board the International Space Station. And then, of course, we're getting ready to, as you mentioned it, the Lunar Gateway. I was just wondering, before we talk about Canadarm3 and get into that a little bit more, just give us a general overview for those out there who might not know exactly what the Lunar Gateway is. Can you give us just a big picture view?
All right. So, I mean, everybody is familiar, particularly, I mean, in the US, you guys are doing boots on the moon. You want to be back on the moon in 2024, right? So that's part of the objective here. But big picture, we want to be able to go back, and we want to be able to do it sustainably. We want to be able to go up, get up there, set ourselves up, be able to do continuous missions. And you look at the progression that we've gone through. I mean, things with the space shuttle and the original Canadarm, great, real big, monumental step forward, right? Mm-hmm. Then you look at International Space Station. We kept we've kept humans in space for 20 years, right? 2 of my 3 kids have no idea that there was ever a time when there wasn't a human constantly in space, right? It's ever present now, right? And that sort of set the bar so high now. So what's the next thing? Well, you look at, okay, well, so we've been to the moon as a species, but I mean, we went on a camping trip. Now the idea is, can you go back there? Can you set yourself up with a base? Can you do, can you look at, exploiting resources? Can you do it in a sustainable way? So boots on the moon is going to get you there in 2024. But if you want to be able to go there and do it for 10 or 15 years or more, I mean, you need to build up an infrastructure. So the Gateway is basically is proposed to be part of that infrastructure. And what you got there is it's a small station, right? It's not like the International Space Station. The International Space Station's, and it's like, again, I get these goosebumps when I say these things. There may never be another International Space Station, right? Because it was just so over the top awesome in terms of what got put together there and everybody pulling in. Gateway is going to be the same thing, but now we're going long, right? So we're going for the big trip. It's going to be a smaller station. We're going to go out there, do 30-day missions at a time, starting off at once a year. We'll see how things spin up. We'll see what kind of commercial activity kind of centers in on this stuff. And then we'll see what the surface options are going to be and how we play a role there. And Gateway is really going to be that, that gateway. It's the St. Louis of heading out into the West, right? So you needed to have that outpost out there to set yourselves up and to be able to have everything kind of congregate in terms of preparing for your surface missions. So you can now fly out logistics, you can bring crew there, you can bring equipment there, you can bring your landers there, set up your vehicle, go down to the lunar surface. Now you've got a command post that's permanently set up. You've got a place to do the science that kind of proves the whole environment and how you're going to be able to live in that environment and do the long-term things and do all the things we have to do on space station to just figure it out and put it all together. So it really winds up being that kind of key building block kind of step to setting ourselves up in deep space and really going out to the next level.
See, that's wonderful. Now, Canadarm3 is obviously Canada's contribution for the Gateway. And I'd love to talk a little bit more about just how it's sort of a step up. I know it's smaller in size than Canadarm2, but then again, it's got cutting edge software and artificial intelligence. Can you tell us just a little bit more about the differences between 3 versus 2?
I guess let me start off with Canadarm2, right? So Canadarm2, we built this awesome, massive robot, right? Like it's really like when we bring people on tours of the agency and stuff like that at CSA. We bring people into the high bay and we've got a full size 1-to-1 scale mock up there, and people look at it and they go, wow, I had no idea, right? And then you start telling me you pick up things like school buses, right? And then you put them together into basically what are berthing interfaces that are the size of like a sundae cup, right? And and you explain how you can't really see everything. So we put that together, that system, and then we added Dexter to do all the fine stuff and everything. So it's really a nice, it's a nice system, right? We've got all kinds of capability there, but we went big and we kind of did things the hard way in some ways, right? So we did a lot of stuff, like we built a robot that was going to be, totally user centered. It was going to be astronauts operating it all the time. Interesting point, right? We do almost all our operations now by ground control, right? Dexter operations are done exclusively from the ground, right? And we had to change, we figured all that out on the fly, right? We got busy with space station, the crew got busy with space station. Like it's a big vehicle. It takes a lot to keep that thing going, right? It's like maintaining your house. It's just constant work. And you got half the crew's time is spent checking on all those systems. The other half, you want them to be doing the science. You want them up there doing all that cool stuff and getting all that benefit out of being up there, right? So part of the idea with going to ground control was let's demonstrate that we can do all this stuff. We had to prove it all out, prove that we could do it safely, come up with all kinds of tricks and tips on how we were going to set that up. We re-architected the software completely on the Canadarm2 and Dexter, right? We've now got that capability. So right now, the only things that crew are actually doing is they do free flyer capture, right? So if a vehicle, like a visiting vehicle like the Japanese HDV or, what was previously the original Dragons, Cygnus is still coming up this way. So they fly up to the space station, we reach out with the arm, grapple it, and then we actually made it to the station, right? So they do those operations, and then they do the EVA, the spacewalking support. So, we're moving the astronaut around on the tip of the arm, and, the crew members really like to be kind of close and tight on that one, right? So they want a guy inside the station, the guy on the outside of the station, talking constantly. Right. So when we look at Gateway now, we're going to take all these tricks and tools that we've got and all this capability that we built up, and now we're kind of summing it up into this nice, tight little package, right? It's going to be a little different. So we're going to go with, one larger arm. I mean, this is the current concept. We may still change things around a little bit because we're still toying with a few ideas on this. But now we're kind of going with a small arm operating on a big arm. So, like on the space station, we've got this big arm, and, to explain it to people, maybe who aren't as familiar, I mean, Canadarm3 was this symmetric arm with both ends could be the base or the tip, right? So you got this inchworm effect where you can walk the arm around on the outside of the space station and really build up this massive vehicle. Well, we're going to go with the same kind of flexibility with the Canadarm3, but now we're actually going to incorporate a small arm into this, and that small arm might actually do things like walking around on the big arm. So this whole idea of kind of like giving yourself that flexibility and having these intuitive solutions to be able to do all these things in a different way for robotics, being able to do that, from the ground. And then of course, the next step here, the real big step is going to be when we look at, operations in deep space, right? So you're going to talk about a vehicle that's going to be, there's going to be times where it's going to be unmanned 10 or 11 months at a time, exactly. Right? At least initially anyway. Mm-hmm. So it becomes really important to be able to do everything you can as autonomously as you can, right? Because I mean, this is going to be one of the things we have to learn about working in deep space. Is you got to be prepared to be on your own and be deep in the woods here and be able to take care of yourself, right? Exactly. Mm-hmm. So the idea with that is we're going to set up on Gateway. We're going to try to have as much autonomous capability as we can. To get there, we got to go and do the things we know how to do where we can do them. So we're going to go and prove that out on space station. So we're going to do yet another upgrade on the Canadarm2. We're going to bring in autonomy and all that different level of control and scripting, supervised autonomy, and all that capability. We're going to introduce it on the space station. We'll prove it out there, show that, okay, now Canadian Robotics can take it to this level, mm-hmm. Demonstrate what we can do there. And now when we go in deep space, we can do that stuff because I'm going to tell you, in deep space, it's not the place you want to do things for the first time.
Definitely not.
You want to be able to do things like our vision is we should be able to walk around and reconfigure the system autonomously, set that up from the ground, obviously set up all the safe conditions for it, but be able to pull the trigger and have all the conditionals checking to make sure that everything is going exactly as planned and that it can execute those steps with the proper safety checks in place, and then take that and expand that all the way to the idea of doing things like potentially doing free flyer vehicle captures. So again, you want to go on the big camping trip. Wouldn't it be great if you just got there and the canoe was already there and all your supplies were there and the firewood was there? That's what you want to be able to do on these trips. So you want to be able to send a logistics vehicle out in advance. So sure, we can dock that, but a lot of the stuff you want to be able to do is to configure those vehicles and move things around. So the robotics have to play a role in there. We think we can probably capture that vehicle. We can make it to the station. We can unload that vehicle. We can configure a vehicle like a lander. And then when the crew arrive, you're already halfway there. You've already got the canoe is already packed and ready to go. And that's the way you want to do it. I mean, that's really like when you look at it in these silly analogies, like a camping trip and stuff like that. I mean, like that's what you'd really like to do. Wow, wouldn't it be great to go on a trip like that where you're going like on a serious hike and you've got everything sort of set up and been prepared for you, right? So I mean, that's kind of the Canadian vision of our contribution. We really want to go all in on this, bring all that capability onto the table. So, one of the things we learned from ISS is we evolved so much. We upgraded the system, we boosted the capability, we brought in new tools, we brought in all kinds of extra capability. For Gateway, we kind of want to start from there and bring all that stuff to the table so that when you look at what your options are for what the future can bring in terms of these future missions, I mean, I really want Canada to be that step-up partner again and say, yeah, we can do that. Let's do this thing and let's actually go to that and bring everything to the next level. And then hopefully this turns into going right to like the lunar surface, who knows, rovers, habitats. I mean, who knows where we're going to go with this stuff, right? It's all kind of coming together now and it's exciting. But it's exciting to think about what more we can get out of this.
Ken, I tell you, you have the best analogies.
I've heard that before, you know.
Yeah, I haven't heard one where you talked about potato salad as you're talking about the Canadarm3.
Where did you hear that one?
I read it on an article. I can't remember exactly what that was, but it was just these awesome analogies. And that was one of my questions: is how do you test this? And I like how you actually making plans to upgrade the ISS Canadarm2 for this technology to prove that. I think that is just wonderful. Also, another thing I was really impressed about is just, I guess, another difference that's in the plans is that the range of motion for the Canadarm3 is actually almost 360 degrees for the 7 joints, if I have that right.
It's actually more than 360 degrees because we can actually revolve and go past itself.
Really?
Right? So it's actually more than 360 degrees because if you think about it, if you got to 360 degrees and you had to extend out to somewhere, you would never want to get to that point where you couldn't actually sort of, are you telling me I have to go all the way back around? So we actually kind of built that ability to go full revolute like 1.5 times. And like you said, on all 7 joints, and it's a symmetric arm, right? So you even get into the scenarios where you talk about, let's say we had a failure in one of those joints.
Right.
We've actually, we went through that, right? We had a failed wrist joint on the arm. And we basically showed how we can actually work around that failed joint and then change out that joint. The great thing with Canadarm3 is, again, we're going back in ISS history books here and reminiscing or whatever, but, it was great that we built the Canadarm2 where we could actually change out that joint, fix it up in one mission, one spacewalk. We were able to get back in the game again and then keep on going with building a space station, right?
Yes. In
Canadarm3, we're gonna have a little robot to fix the big robot, right? So the whole idea here is you want to take all that stuff out of the picture. You don't want to have to rely on having to do something dangerous like a spacewalk, especially in deep space, right?
Right.
And again, on ISS, we prove that out. Like with Dexter, we change out our own cameras. Cameras are tough, right? Cameras fail.
Yes.
So why
would you have 6
color
color cameras on this one too?
Yeah.
Right. 6 color 4K cameras, which again is incredible. But one thing I have to say, I'm really impressed too, is just the maintenance. Of Canadarm2 and even the first one, these last for years. They're designed so well on this. And I was just going to ask, what is the life expectancy, if I can ask, of Canadarm3? It's going to be in deep space, obviously. How do you quality control something so well to make it last so long? I'm so impressed so far.
So what we're doing for Canadarm3, I'll start by saying this, right? Canadarm3, the idea is here we're going with a baseline 15-year operational life, okay? And we already know that we're going into this with our eyes open and saying, we clearly want more than 15 years, right? I'll go back to Canadarm2 and tell you what we did there, right? With Canadarm2, just based on the fact that we built the spares and we had that outfitted in such a way that we've got the necessary spares on orbit on ISS. So if we have a critical failure, we've got the critical spare available. We've got the capability to bring stuff up and down with the different vehicles, whether it's externally or internally inside the pressurized volume. Because remember, we brought back a latching end effector, which is it's a big piece of equipment. We actually brought that back inside a capsule, right, and had it refurbished, right. So the operational lifespan for the MSS is basically undefined. There's no reason why you can't just keep on going as long as you've got the necessary spares. So it becomes, you want to have a robust design in terms of building things to last, but you want to have a robust design in terms of being able to change out parts and having the tolerance for failures to work around stuff, so that when you get into a problem, you can work around it for a little while and then set yourself up, fix yourself up, and then just keep on going and get right back to your nominal baseline. That's the approach that we tried to take all the way through this. And it's been a great approach. And you just see the evolution of it, right? So, Canadarm, the original Canadarms, they would go up on the shuttle, but, they had the luxury of, they'd take them off the shuttles and they'd do a complete refurb on them, make them brand new again, right? So, of course, that thing worked like it was a perfect machine every time, right? You look at it and go, hey, look at that Canadian hardware. Life was easy on shuttle, right? On space station, we have to go for the whole 20 years plus here, and we're still, like, as far as I'm concerned, we're good to 2030 on Canadarm2 and Dexter, right? We'll have the necessary spares, and again, we progressed the solution. We took the hardware approach on this, and we've got like the logistics there to back it up, and there's no reason why we can't keep on going. On Canadarm3, I think it gets a little tougher, right? Because now we're going in deep space. So now you get into radiation and stuff like that.
Right.
I'll tell you, a big worry for us is dust, right? Because as you start going back and forth between the lunar surface and the gateway, it's like getting dust in your tent.
Yes.
It just goes back to the camping analogy, right? It just, the dust kind of gets into everything, and you find yourself, the next thing you know, you're kind of eating your food and you're going, I got sand in my eggs here. Like, this is not where I want to be, right? So that's something like on Canadarm3, we need to look further. We need to go and wring this stuff out, right? Again, the Canadian approach on this is we're doing this contribution for Gateway, which is the Canadarm3. We're also we've got something called a Lunar Exploration Accelerator Program, right?
Yes.
And so this LEAP program, right, LEAP, we're looking at doing contributions that are going to the lunar surface, and we're looking at a variety of different ways on how we're going to get there and everything like that. And we've got a few options on the table and stuff like that. But one of the things we look at doing is, why don't we do the dust mitigation right there at source? And if we put the locomotion system on a small rover and we get that on the lunar surface, those bearing rings and stuff like that in the seals, let's prove it out there where it's at its worst. And then if we bring that back to what we're doing on Canadarm3, piece of cake, right? So we're trying to look at it that way and try to look at it in terms of like really going in with the all-in kind of approach on this.
Ken, this is incredible. I know these are probably hard to predict, but what is your rough timeline for, like, when can we expect Canadarm2 to be updated on ISS? When can we expect Canadarm3 to launch? What timeline are you looking at?
So the goal line right now is set at 2026.
Okay.
Right, and that's just crazy aggressive, right? We're going full tilt. We're set to do it. I mean, we've got there's definitely challenges. I'm not going to lie, right? We got a lot of stuff to work out, and we got a few little problems to sort out and everything like that. But honestly, everything on paper right now looks pretty good. Like, we're set for late 2026 would be when we'd be good to go. And that's you also got to consider now. They want to start putting up this small space station, this gateway. You got to have all the base points preset on those modules that are going to be put together up there.
Right. Anything
that goes up as a payload. So let's say you've got an experiment payload that you want to be able to have on the gateway, and you want that thing running from day one, right? Like they launch, the PPE and Halo module in 2023, and there's going to be science going on from then on, which is absolutely what you want to be doing. But realize you want to be able to switch that out. You want to be able to do different stuff and give everybody a kind of a shot at the batting order here, right? So robotics is where we're going to do that. I mean, that's going to be a big deal in terms of, that Canadian contribution. The space robotics is going to enable utilization on Gateway. It's going to allow us to move stuff around, stack it up, move things in and outside of the vehicle, bring it in and off of logistics vehicles, bring stuff inside. So if we want to send stuff back to Earth, like via the pressurized volume, we're going to be able to do all that stuff and interact with an airlock, etc. All that stuff, all those interfaces are all being figured out right now. Like, we're deep into that stuff, setting ourselves up so we can deliver interfaces for 2023, get that stuff on the modules, and then when the robot shows up on 2026, it's game time.
Again, Ken, I just want to congratulate you and the Canadian Space Agency for all your amazing successes so far. We're so excited about the future and your involvement and contribution for the Lunar Gateway. Thank you so much, Ken, for taking time to join us. Really appreciate it.
Look, Chuck, I want to thank you as well. I mean, I love doing interviews like this and stuff like that, because when I get those goosebumps, it really reminds me how fortunate I am. I really look at my job as being, I'm just glad I came in where I did, how I did, and how everything lined up for me. I'm glad that I'm a citizen of Canada, and Canada's a player in this. I'm glad that we've got a partner like the U.S. and we've got NASA to really bring forward this leadership and provide these opportunities, and really that we work it together. Like, I mean, it's a valuable and productive relationship, and ISS has been an experience for the history books. And I look at Gateway and I can't wait to get into this stuff.
See, Ken, I think that's wonderful. Again, I thank you for your enthusiasm on that. Again, I think just the future of space exploration, we have to work together. That's the only way we're going to, just the sum of our parts just are going to get us so much farther than that. So again, Thank you so much. Appreciate it.
I appreciate that message on working together more than ever.
Your space journey.
Well, I really enjoyed my conversation with Ken, and I'm excited about the future for the Canadian Space Agency, especially the Lunar Gateway. It's going to be exciting to watch that progress. Anyway, I want to thank Ken for joining me today. I want to thank you for joining us as well. I want to encourage you to subscribe so you don't miss a future episode. We'd also appreciate it if you'd share this episode with a friend. Thanks so much for joining us today. We'll see you next time. God bless.